In this video, I'm going to teach you about saving the state of a game to disk for later loading, commonly referred to as saving and loading a game. There's no built-in functionality for adding a save game in Unity because saving a game is unique to the game. Each game has a different set of data that needs to be saved and loaded to represent the game state. This video will cover both PC and mobile games as well as web. There is a distinction between the two because web games are more limited platform, in this case with tighter security. We don't have the same freedom to read and write files on the system when using the web. Since saving is so specific to the game you're creating, in this video I'm going to focus on the general techniques used to serialize objects. Let's take a look at the code. Here we have a save load simple objects class. It's going to handle saving and loading for us. In this case, when writing simple objects, which are a type of object in our scene, we're going to open a file, collect a list of all the simple objects in the scene, create a new binary writer, and write the number of objects that we have. And then each object in our list is going to write its own state. Let's take a look at that. Writing the object state is going to accept that binary writer we created before, and it's going to collect a list of its children and write the number of its children, and then each of its children are going to write their own state. This is a typical pattern when doing recursive serialization. Each object will be responsible for writing its own state when called upon. Finally, this object is going to write its own state at the end. Let's go one deeper and take a look at this sub-object writing its own state. The sub-object has no sub-objects of its own, so it's just going to write its own state and then return. So let's take a look at reading. When reading a save file, we're going to open our file, create a new binary reader, and from the file, we're going to get the number of objects we need to read. And for each of those objects, we're going to create a new object, create a new script, and then have that script read its own state from the file. Let's take a look at that. When an object is reading its own state from the file, it's going to get the number of sub-objects it has. And for each of those sub-objects, create a new game object and create a new component. And then that component is going to read its own state. As you can see, this is identical to the write procedure, where we write the number of objects, and then each object writes its own state. Saving and loading are going to be mirror images of each other, because when writing state in this way, the data is in a precise order to make reading and writing simple. This means the data is byte for byte exactly the same order when we save and load. If we're off by 1 byte, we'll throw off the entire sequence. Let's go one deeper and look at the sub-object reading its own state. We see that once again, it has no sub-objects, so it's just going to read its own state and then return. Let's take a look at this in action. We have a couple simple objects here with some sub-objects below them. And we have our simple saver loader. We'll hit play. Now we just hit S to write the state, which creates this save file. Now we can actually delete these if we wanted to, and hit L to load. And we see that we've loaded again the exact same state from each of the objects. And we can actually delete these multiple times and load as many times as we want. The web version of this is nearly identical, except the web version is limited to a dictionary key system. When using the web player, we have restricted access to the hard drive. We can only access the player preferences file. This is limited to 1 megabyte. Data is stored by a string reference, and we can only store strings, floats, or ints. It's possible to abuse this system to utilize the same method as we did before, creating a key structure to allow us to set unique keys for each object. In this case, we're going to do the same thing, where we get the number of sub-objects, write the number of sub-objects to the player preferences file, and then for each of the sub-objects, they will write their own state to the player preferences file. This is not an ideal system for web games, since we are limited to 1 megabyte and can only store strings, floats, and ints. In a web environment, the ideal situation would be to use a database. A similar tactic for serializing data can be used in databases. We can break apart the serialization by object and store into tables, or it can combine together into a single binary data blob. In this video, I've taught you a simple strategy for saving games. There are a lot of different strategies for saving games, and they vary depending on the game type, game mechanics, requirements, and even the developer's personal style. Some games will only ever need to save the high scores because the game state doesn't persist beyond that. Other games will need to save the state of hundreds of objects, with each object having dozens of data structures that need to be saved as they are. The strategy I've shown you here is just one of many. Choosing the right strategy for your game is an important decision, and it's one only you can make.